Hello everyone and welcome. In this short video, you will see how to identify and fix processing skew issue in IBM PureData System for analytics. Skew is often caused a single query or a system-wide performance problem. It indicates an unbalanced amount of work taking place one or a subset of all active data slices. There are two different kinds of skewing that can negatively impact the system performance. First one is a storage related, also known as table or express skew. When data is loaded to a table, the rows are distributed to a particular data slice based on the distribution key, assuming distribution is not defined as random. The data slices holding a larger count of table rows will generally work longer, harder, and consume more resource to complete its job. These data slices can become a performance bottleneck for the queries. This uneven distribution of table rows is known as storage skew. A query will need to process table data in various ways to produce the final result set. Along the way, NPS creates intermediate tables to filter projects, sort, and aggregate data, along with broadcasting and redistribute data. This intermediate table may produce an uneven distribution which can negatively impact the query performance. This kind of uneven data distribution called as processing skew. Processing skew is introduced during query execution. For example, if you distribute a table on a date column, information might be evenly distributed on all data slices. But parallel processing will not come into play when all of the records to be processed for a given query are located on just a single data slice. This type of skew can occur as a result of large data redistribution during query execution. System catalog doesn't contain any information that could allow you to do early detection of processing skew. This type of skew are difficult to identify and need good knowledge of overall table structure, SQL, and plan flow. During join two tables, if matching rows of tables are physically co-located on same device, then no data get redistributed. Thus, there is no processing needed. But if the rows in join tables are not physically co-located, optimizer needs to move data on tables to co-locate them. That means either broadcast one of the table to every spool. With broadcast table, there is no skew, as all spool will receive the same copy of the broadcasted table. But broadcasting large volume of data takes time. Other way data get co-located on the fly by redistribute table. If a table get redistributed during a query, it could result in processing skew. It's only happen when a large number of records are involved or the column on which it gets redistributed have lot of duplicate values. To detect processing skew, you need to monitor the spool's swap space usage while executing queries. The NC spool swap space command provides a summary of swap space usage for individual spools. It also shows swap space used by each active plan. In this example, the plan ID 122 is highly skewed. Only one of the 120 data slices on the system is used all of the swap spaces, whereas plan ID 1390 is causing no skew. The NCSQA swap space sys command shows swap space statistics for the system manager. You can easily identify if the system manager is running low on free swap space, and it can be an indication of processing skew. You can use nzresponders command to see how query snippets is responding against data slice as it's running. We discussed about it in the storage skew section earlier. In case of a processing skew, if query failed once, it will always fail unless data volume changed. Typically, dboss log, pg log will provide appropriate message for running out of swap space. The DS ID in the error message indicates data slice number that ran out of swap space. Similar kind of message can be found in the plan file too. You can find the indication of processing skew from the query plan file. As processing skew often occurred with the data redistribution, pay attention while reviewing plan file. Check snippet associated with the performing distribution. For example, snippet 6 is having long execution time, which is an indication of processing skew. The detail line that associated with each query snippet provide valuable information about processing skew. You will see this line only when it applicable to the particular snippet. You can use the CPU, tread, and twrite values to identify skew. All three columns shows average and max SPU resource usage. If there is no difference in the average and max, it displays only one value. The detail line only displays those columns which applicable to the snippets. The dread and dwrite are not in this output, but those can also be used for skew detection. The CPU column shows average and maximum SPU CPU usage in seconds for each query snippets. Similarly, tread and twrite shows SPU temporary disk read and write in seconds. The dread and dwrite shows average and maximum SPU data disk read and write by snippets. Anytime you see a difference between average and max value, it indicates some SPUs working harder than others because of processing skew. In this example, all 4 snippets showing some difference in average and max value with SPU, tread, and twrite, but the snippet 5 is having the biggest gap in average and max value in all 3 resource columns. Here is list of things that can help you to fix processing skew issue. Force the optimizer to broadcast smaller of the 2 tables rather than redistribute the bigger table and cause possible skew. There are 2 optimizer parameters, enable factorial planner and factorial threshold size, can help you to prevent a broadcast of fact data. A bad statistics can influence optimizer to make wrong decision that can cause processing skew. You should run full statistics on tables that involved in join. Many times a bad query logic can cause processing skew. Instead of tuning optimizer parameters or masking the data, it is always better to rewrite bad query to address processing skew. Hope this video gives you some idea to tackle skew in NPS. Thank you for watching. Goodbye until next time.